Solving multi-step inequalities is simply piecing together what you had done in the last unit of multi-step equations with what you know so far in this unit of inequalities. So our target is I can solve multi-step inequalities. So remember this, inequalities are solved almost exactly like in equations, with that one exception being when you undo multiplying or dividing by a negative. So the ultimate goal of solving any inequality is to isolate the variable, get it on one side of the inequality symbol by itself, and yes, I want you to write this again, lazy bones, write it again because it's important. This needs to be absolutely etched in your memory forever and ever. How do we go about this? This is your how-to. This is multi-step inequality, so you need a system of what you're doing first. You are going to need to clean up the, well, not the equation, right? The inequality before undoing. And so that's going to be where you have to apply the distributive property and also combining like terms, just like you did with those equations. Once everything is cleaned up, then it may be that you need to reunite the variables. These two things of cleaning up and reuniting the variables aren't going to apply to every single inequality, but it may, and so that would come after you've cleaned everything up. You reunite those using inverse operations. Then undo what's happening to the variable using inverse operations. Addition and subtraction undo each other, multiplication and division undo each other, and remembering right here, right there, don't forget to switch the inequality symbol if you multiply or divide by a negative. If you're undoing multiplying or dividing by a negative, you have to switch that inequality symbol. You can catch those times when you miss it by substituting in a number from the solution set to see if it makes a true statement. So let's try this one. 4 times the quantity 3n minus 1 is greater than or equal to 2 times the quantity n plus 3. You're going to clean it up by using the distributive property. 4 times 3n is 12n. 4 times negative 1 is negative 4. Now on the right side, distribute the 2. 2 times n is 2n. 2 times positive 3 is positive 6. It's cleaned up. Now I'm ready to reunite the variables, and we're going to move the lesser coefficient, which is 2n. I'm going to move 2n by subtracting 2n. That's the inverse of it. And once I do that, I have 10n minus 4 is greater than or equal to positive 6. This canceled right here, so 6 comes down. 10n is 12n minus 2. Now I'm ready to undo. I'm going to undo subtraction by adding 4 on both sides. It cancels on the left. I'm left with 10n is greater than or equal to 6 plus 4 is 10. Then I'm going to undo multiplying by 10 by dividing both sides by 10. And the result is n is greater than or equal to 1. Now there are going to be some special cases, just like you saw with equations. And what was the special case was in your undoing, the variable terms disappeared, where all you were left with was a negative, was constants. So whenever I go to clean this up, it's cleaned up on each side. So I'm going to reunite the variables, and since they are the same variable, it doesn't really matter which one I move. So I'm going to subtract 5 and do the same thing on both sides. It cancels here and here. So what comes down is 9 is less than negative 1, which is not a true statement. Since 9 is never less than negative 1, there is no solution. So what made it special is the variable terms cancel because it's the same on each side, and what you're left with is a number compared to another number. And since 9 is not less than negative 1, it's a false statement, meaning there is no solution. There is nothing that I can put in there for n that's going to make that inequality true. Here's the other kind of special solution. On the right side, I can see I need to clean that up. 7x combined with negative x is 6x. And there I see that again. I have the same variable term on both sides. I subtract 6x. It cancels here and here. So what comes down are numbers. 8 is greater than 2. Now this is a little bit different. 8 is always more than 2, no matter how you describe it. 8 is more than 2. So since that is always true, the solution is all real numbers. It does not matter what I put in for x. I can put anything in for x as a solution, and it will be a true statement.